The next type of identities that we're going to go over, I'm going to do this a little bit out of order of what the book does, is the odd-even identities. And so you may have remembered from the drawings of each one of the functions on a rectangular coordinate system that some of them had symmetry around the x-axis, or excuse me, the y-axis, and some of them had symmetry around the origin. Okay? Each one of the trig functions is either even or odd. Okay? And so what's important to know there is, if you remember from our discussion in the past, we'd say a function like x squared was even because if I put in the f of 5, I'd get 25. If I put in the f of negative 5, I would get 25. And if we had an odd function like x cubed, and I took something like the g of 2, that's 8, g of negative 2 would be negative 8. So I get the same number, different sign on an odd function. I get the same number on an even function. So how does that apply to the trig functions? There are 4 odd functions and 2 even. Sine of x is odd. So if I took, say, the sine of negative 30 degrees, that's the opposite of the sine of 30 degrees. So the sine of negative 30 degrees is negative 1/2. The sine of 30 degrees is 1/2. So I need to have a negative in there to show that they're the same. Tangent is an odd function. So the tangent of negative 30, I already forgot my 30, 60, 90s. So if this is 30, this is 60. 1, 2, square root of 3. Tangent would be opposite over adjacent. This would be the opposite of the tangent of 30, which tangent of 30 is negative 1 over the square root of 3. This would be negative 1 over the square root of 3. Both of their reciprocals would also be odd. So since cosecant is a reciprocal function of sine, it's an odd function, and cotangent is a reciprocal of tangent, so it's an odd function. The even functions are cosine and its reciprocal, secant. So if I take the cosine of negative 60 degrees, I get square root of 3 over, cosine of negative 30 degrees is square root of 3 over 2. Cosine of 60 degrees is 1/2. If I take the cosine of positive 60 degrees, I also get 1/2. So sine, tangent, cosecant, and cotangent are all odd functions. Cosine and secant are both even functions. The last identity in this section is dealing with cofunction identities. And so you may have noticed when we did all the pictures again that they just look very similar to each other. Sine and cosine are just a shift. That's what we mean by the cofunctions. So the cosine of theta is exactly the same as the sine of theta, pi over 2 minus theta. The tangent of theta is the same as the cotangent of pi over 2 minus theta. The secant of theta is exactly the same as the cosecant of pi over 2 minus theta. I could write these in the other way also. I could say the sine of theta is equal to the cosine of pi over 2 minus theta. I could say the cotangent of theta is equal to the tangent pi over 2 minus theta. And I could say the cosecant of theta is equal to the secant of pi over 2 minus theta. Remember, pi over 2 in radians is the same as 90 degrees. So basically we're doing a horizontal flip, and then we're moving to the right 90 degrees. And so all this would look identical. Each one of these functions, their graphs would look identical if you do a horizontal flip and a move. We won't use this a ton, but it is an important thing just to say that look how similar to these functions are to each other.